Hi, Assalamualaikum. My name is Naraini binti Syamsatma and we'll be presenting sleep health and lifestyle by using Weka dataset. Sleep health is a critical component of overall wellness with sleep disorders and poor sleep quality linked to numerous physical and mental health issues. Furthermore, lifestyle factors such as physical activity, stress levels, and body mass index (BMI) can significantly impact sleep quality and overall health. In this study, we aim to investigate the relationships between sleep health, lifestyle factors, and various health outcomes using comprehensive dataset that includes information on sleep duration, sleep quality, physical activity, stress levels, BMI, blood pressure, heart rate, daily steps, and the presence of sleep disorders. By using the Wake Machines learning tool, we will apply various classification algorithms to predict health outcomes based on the available lifestyle and sleep-related variables. Next is problem statement. The goal of this analysis is to develop predictive models that can accurately classify the sleep health status of individuals based on their lifestyle behaviors and other related factors. The dataset contains a wealth of information on various aspects of sleep health and lifestyle, including sleep quality, physical activities, diet, and mental health. The primary objective is to leverage the machine learning algorithm in Weka to build models that can predict the sleep health status of individuals, which can be categorized as good, moderate, or poor. This analysis has to be potential to provide valuable insight into the key factors that influence sleep health and inform targeted interventions to improve overall sleep quality and well-being. Next is methodology. In order to get the data for the analysis, the author started by extracting the data from Kaggle and download the dataset from sleep health and lifestyle dataset. In this study, the methodology for the study on classification algorithms for sleep health and lifestyle dataset by using Weka involves several steps. Initially, the dataset is collected and pre-processed to ensure data quality by handling mean imbalance and normalization. The analysis is divided into three methods, which is classification, association, and attribute selection. Classification is performed using decision table tree, J48, Bayes, and Bayes-Net algorithms to categorize the data. Association rule learning is conducted using the FRI algorithm to discover and interesting relationships between variables. Attribute selection involves using info get attribute eval and correlation attribute eval to identify the most relevant features, improving the efficiency and accuracy of the models. Finally, the results are compiled and visual to provide clear and interpretable insights into sleep health and lifestyle patterns.
The algorithm creates a simple interpretable model based on a table of rows. Trees J48 is an implementation of the C415 decision tree algorithm, which builds a decision tree by splitting the dataset to achieve the highest information gain. Bayes-Net uses a probabilistic graphical model to represent variables and their dependencies, applying Bayes' theorem to compute probabilities. Our finding provides insight that can inform personalized health interventions and preventive strategy targeting sleep and lifestyle-related risk factors. By understanding the factors contributing to sleep disorder, we can develop targeted approaches to improve health outcomes. Our study aims to enhance the understanding of the relationship between sleep, lifestyle, and health in the modern era. The predictive models we developed can guide health interventions and strategies. So next, I will talk about data processing. The data from this research was collected from Kaggle dataset, sleep health and lifestyle dataset. Initially, original data consists of numeric value. To enable the associate analysis and others, we have transformed the data to nominal data types. Table 1 shows the selected attribute with their possible value. Starting with gender, this attribute categorized individual by gender is the nominal data types. The dataset shows two categories likely representing male and female with count of 189 and 185 respectively, indicating an almost equal gender distribution. Next, we examine age, which group individuals into different categories. This is also nominal data with 4 distinct age groups represented in the dataset. The count are 94, 136, 86, and 68, showing a various age distribution among the individuals. Moving on to occupation, this attribute categorizes individuals based on their job or professional role is nominal and includes several categories with count of 71, 73, 64, 40, 37, 4, and 2. This indicates a diverse range of occupation among the participants. Also, some categories have significantly fewer individuals. Sleep duration divides individuals based on how long they typically sleep, categorized nominally. The dataset shows counts of 96, 78, 132, and 78, suggesting categories like short, average, and long sleep duration. The average sleep duration category has the highest count of 122 individuals. The quality of sleep attributes assesses the perceived of or measured sleep quality among individuals. There is another nominal attribute with 4 categories showing counts of 12, 105, 77, and 109. A substantial number of individuals report good sleep quality as indicated by the high count of 109 in one category. The physical activities level classify individuals based on their physical activity. This nominal data is distributed across categories with count of 82, 78, 70, 71, and 73, indicating a fairly even distribution of physical activity. Stress level is categorized to understand how individual reports or exhibit stress. This attribute also nominal show count of 141, 120, 67, and 56. A significant portion of the individuals fall into the higher stress level categories. The BMI category sort individual based on their body mass index classification. This nominal data reveal count of 195, 148, 21, and 10, with most individuals falling into the normal or overweight categories, providing insight into the population weight status. Blood pressure categorizes individuals into different blood pressure range and is nominal. The dataset shows counts of 65, 45, 4, 3, 2, and 2, indicating fewer individuals in the extreme blood pressure categories. Next, heart rate groups individuals according to their heart rate measurements. This nominal attribute shows counts of 241, 109, 12, and 12, with the majority falling into the normal heart rate range. Daily step measure the number of daily steps taken by individual, categorizing them nominally. The counts are 70, 78, 70, 78, 138, and 105, suggesting most individuals are in the moderate activity range. Finally, the sleep disorder attribute indicate the percent of sleep disorder among individuals. This nominal data show count of 119, 78, and 77, revealing that a majority do not report sleep disorder. In overall, most of the respondents' sleep disorder are classified as high, dark blue, followed by average, represented in red color, and low, light blue.
So now I will present about feature selection. Feature selection discovers most influential attributes using correlation with attribute evaluation and info get attribute attribution when using Weka. As you can see at the table 2 and table 3 for the dataset, it shows that the most contributors factor will be 9, 3, 8, 6, 11, 5, 4, 2, 7, 10, and 1 for information gain ranking. However, if we look at the table 3, the correlation evaluation for extracurricular will be 8, 11, 10, 3, 2, 4, 1, 9, 6, 5, and 7 as shown in the table.
Okay, next I'm going to explain about the specifying the selected algorithm in classification. Basically, we have various classification methods, which is a decision table, JRIP, 1R, BART, 0R, Bayes net, naive Bayes, and also the 3J48. The accuracy of the classifier was accessed by using the Weka tool on the dataset that containing 374 occurrences and also 12 characteristics. So, the effect of employee productivity level dataset were classified with the three sets of classification algorithms, namely decision table, 3J48, and Bayes net that resulted in more than 18% precision. Okay, now let's move into classification algorithm selection. Okay, basically we have choose top 3 highest classification algorithm that I have in our data set, which is the first one is decision table with accuracy of 91.97% and have 344 correctly classified instances and 30 incorrectly classified instances. While the next one is 3J48 with 91.71% of accuracy, and they have 343 correctly and 31 incorrectly. And the last one is a Bayes net with accuracy of 90.37% and correctly classified instances of 338 and incorrectly is 36. So that is the 3 highest percent that we can actually conclude in our classification algorithm selection. Okay, next is association rules result. Association rules results are used for data analysis to discover common if or then patterns. The main connections are determined by using support and trust characteristics. So in overall of our a priori table, the most contributing factor to the patient to sleep disorder are being dominated by one best rule, which is BMI category normal. Because this is because BMI category normal is the most common if or then pattern.
So next, the division 3. The division 3 illustrates the predictive model for insomnia based on BMI category, blood pressure, and heart rates. Initially, it distinguishes individuals based on BMI, where those who are not overweight are predicted not to have insomnia. Overweight individuals are further assessed based on their blood pressure. Those with a blood pressure of 130 per 85 or higher are also predicted not to have insomnia. For overweight individuals with blood pressure lower than 130 per 85, the heart rate is considered. A heart rate less than are equal to 70 by 25 predict non-insomnia. A rate between 70 by 25 and 75.5 shows a small occurrence of insomnia, and a rate above 75.5 is associated with a higher occurrence of insomnia cases.
Right now, I want to present about the visualization for trend analysis. From our finding, here is the best 5 figure that shows the sleep health and lifestyle based on dataset. First of all, there are 3 options of answer that can measure the sleep disorder. Firstly, none, which individual does not exhibit any specific sleep disorder. Insomnia, which individual experience falling asleep or poor quality sleep. And last is sleep apnea, which individual suffer from pause in breathing during sleep. Here is the first figure that shows connection between quality of sleep and gender. It shows that for female, there is a significant cluster of data points in the 7 until 8 hours of sleep range, indicating no sleep disorder or insomnia, suggesting females tend to experience more healthy sleep patterns in this duration range. In contrast, males show a higher concentration of sleep apnea, which is rate points across the lower sleep duration categories of 6 until 7 and 7 until 8 hours, indicating males are more susceptible to sleep apnea compared to females. This scatter plot is designed to explore the relationship between people's occupation and their body mass index, which is BMI categories, with the different color representing various types of sleep disorder. From the figure, it shows that nurses appear to have a higher incidence of sleep apnea, and salespersons have a higher incidence in insomnia, while other roles like software engineers and lawyers show a more diverse mix of sleep disorder types across their workforce. Next, move to the insight this visualization provides regarding the relationship between occupation and gender. From the figure, it shows that occupations with higher concentrations of male employees, such as software engineers and engineers, appear to have more blue dots, which is indicating no sleep disorder across the 6 until 7 and 7 until 8 hours sleep duration range. In contrast, occupation with a higher proportion of female employees like nurse and salesperson shows a greater clustering of red dots, which is sleep apnea at lower sleep duration. Next, a scatter plot shows the relationship between daily start and BMI categories. Looking at the distribution of data points, we can see that individuals with sleep apnea generally have a higher BMI values and lower daily start count than those who insomnia and those who not sleep interference. So this suggests that individuals with sleep apnea tend to have more inactive lifestyle and a higher risk of obesity, which is often associated with this sleep disorder. Last but not least, the data shows that gender and blood pressure levels are closely linked to the prevalence of different sleep disorders. Males tend to have fewer sleep issues overall, with more blue dots, which is no disorder across the range of blood pressure readings. However, as male blood pressure increases, there is a higher incidence of red dot, which is sleep apnea. In contrast, females exhibit a more diverse distribution of sleep disorder with noticeable presence of green dots, which is insomnia, at various blood pressure levels. This suggests that while both gender can experience sleep problem, the specific type of disorder may be influenced by any factor like gender and underlying health conditions like high blood pressure.
So, in conclusion, the study's comprehensive dataset revealed a complex interplay between sleep, lifestyle, and health outcomes, providing valuable insight into the factors that contribute to sleep disorders. The findings indicate that sleep disorders such as insomnia and sleep apnea are closely linked to lifestyle factors, including physical activities, stress levels, and body mass index, which is BMI. Specifically, individuals with higher stress levels and unhealthy BMI are more likely to experience sleep-related problems. The study also demonstrates the effectiveness of predictive algorithms such as decision tree algorithms, which is J48 trees and bias networks, in accurately predicting sleep disorders based on available lifestyle and sleep-related variables. That's from us. Thank you.